All right. The new lighting. Claire, is that you?
Mm-hmm.
No.
I know,
right? I'm the first.
All
right. So, one of the things that we talked about the last time we were together, right, was this idea of the chain of infection, right? So if you can break this chain of infection, you can stop the spread of disease, right? And so one of the important things, right, to consider in the chain of infection, if you go back to that previous slide, is how is the pathogen, right, entering our system? And there are three major ways, right? The skin, the mucous membranes, and the placenta. And I think, remember, when we talk about mucous membranes, there can be a lot of different areas, right? That can be urogenital, right? That can be digestive, and that can be respiratory, right? So there are a lot of things that I think we maybe sometimes forget are mucous membranes. Skin is actually one of the hardest layers to penetrate. It typically requires some type of abrasion, right, or breaking of that epidermal and sometimes even dermal layer for a pathogen to get in. And I don't have it on here. So the most common site of entry for an infective pathogen is typically going to be a mucous membrane. And when I say common and easier, right, it's still very challenging for a pathogen to enter a mucous membrane. We'll talk about that a little bit more actually in the next lecture. Placenta. Again, this is also a very hard barrier to cross. Many diseases can't actually, many pathogens can't actually cross placenta barrier. Some can. And so, for the most part, children, right, that's babies, uterus, or fetuses that are in utero, right, are typically well protected by the placenta barrier. Right? So this, again, is just a little diagram that shows you some of these routes of entry. You can see, right, urethra, vagina, male, penises, anus, mucous membranes, mouth, nose, right, mucous membranes. It doesn't have it going down here, but once it enters mouth, nose, right, it could make its way to the lungs. You can see abrasions to the skin, which can happen from injuries or interactions with insects, right, even ear infections. Infections can also enter through the eye. I don't think this is kind of new to most of you, hopefully, right? And then pathogens, right, have to be able to leave the host, right, if they're going to be an infection that's spread. And typically, right, this is not surprising, the portal of exit is the same as the portal of entry. And we often see for us, right, body secretions are typically a way, right, that things are spread from us. And so if you think about something like COVID-19, right, it interacts with receptors, right, in the respiratory and the GI tract, right? So if you breathe in air droplets that have the virus, right, it can make its way into your respiratory system, and then you could theoretically later on in the infection cycle breathe out, right? So it comes out the same way that it came in. Nothing overly surprising here, a little more detail, but you will see a lot of these sites are the exact same, all right? They've added a couple on here, but still, most of those portals of entry are going to be really identical to the portals of exit, right? Please note, I already pointed this out, portals of entry and exit are slightly different in males and females because anatomy and physiology is slightly different in males and females.
Can I ask a question?
You may.
Okay, so how, I guess when I think of like portals of entry, it's typically like external. So how could an infection start internally, like in the mammary glands or like in the seminal vesicle?
Well, so these were portals of exit.
Oh, portals of exit. Okay, but on the slide before it, there
Yeah. So yes, and yeah. So that's a good question, and that's actually one of the things we'll kind of talk about a little bit more today. And so, what we typically don't think of is even possibly internal injuries. We talk about to like your GI system, maybe allows a bacteria to cross a barrier that it couldn't cross before. So the bacteria is already inside of you. It's part of your normal flora. You have some type of injury that causes a small abrasion on the mucous membrane in your intestine, and then a pathogen could cross. So
okay,
it's possible, yeah, that things can get to places that they shouldn't when you have some type of small internal injury.
okay.
Does that help?
Yes. Would that like sepsis like potentially be an example? Like if you have internal bleeding or anything like that?
I mean, sepsis could be. I guess it kind of depends what caused the sepsis, but you would still, a lot of times, so you could get like pneumonia, right? So sometimes people that have pneumonia, they don't get treated soon enough. Maybe they have a weak immune system. And so that started off as a lung infection, right? It entered the mucosal membrane, but then the infection built and eventually kind of burst out of that membrane. And so, yes, it's something that was already in them, but it still at some point came from somewhere outside to start the whole infection cycle.
Gotcha. Thank
Does that work? I don't know why I'm looking at the screen like you can see me through the screen, but maybe I'll get used to the technology. All right, so epidemiology, we've been talking about that a good little bit. Now we're going to actually kind of get into a little bit more of what an epidemiologist is doing on a day-to-day basis, right? I think we can certainly appreciate that they track, diseases, they keep track of levels. Ooh, small side note, I did actually take a quick look-see at the CDC website, and it turns out that, for that endemic, I think someone had asked, how do we set that endemic level? And it actually just is through years of observations. You just kind of keep track of a population, and you kind of notice, hey, it appears that every year, no matter what, there's kind of this many, infections. Now, it doesn't mean that, again, we don't react to those endemic levels, but that's just years of observation and data gathering, right? So for epidemiology, right, investigation. And so this is looking for cause and effect of disease. And so, yes, ma'am.
Could coronavirus, like the levels that it's at now, one day be considered an endemic?
Could be considered endemic? Possibly. That would be a scenario that a lot of people don't like to think about, because that would mean it's just, again, it's always there. Theoretically, yes. Check back with me in 5 years, right? But it could be, right? We just don't know, right? Definitely, it could be. I think we all hope not, but it definitely could be. And I'll actually talk about an interesting theory maybe a little bit later that I have about that. So especially early on, during the start of a epidemic or a pandemic, right, there is a lot of work that's going on here. And even with the coronavirus, or this rendition of it, right, SARS-CoV-2, this is still an area that we're trying to keep up with and understand, all right? And we'll talk about what they're actually doing. Surveillance, right, monitoring known diseases, being on the lookout for unknown diseases. And again, we'll briefly kind of talk about those MMWR, well, I don't know if I mentioned those yet, but MMWR reports, morbidity, mortality weekly reports that the CDC and World Health Organization use. And then when it comes to the public health branch, hospital-acquired infections, which we'll actually talk about at the end of the lecture, are becoming a huge issue that I think is often underappreciated in today's society. And then these kind of fall in line with best practices in education. And so you see all the CDC hand washing things that we have here, the social distance things that we have, right? That's kind of all part of that group of things. So let's talk about this investigation. So the first thing that you do in investigation typically is something called a descriptive study. And the best way to describe this is the who, what, where, why, when, how, right? They are just looking, right, and trying to identify anything that they might feel is a risk factor for whatever disease or pathogen, right, they're looking at. Now, I kind of look at this as casting a wide net, right? This is just the initial kind of, we're trying to gather as much information as we can, right? Hoping that maybe something sticks out to us, right? So this is kind of that initial study, right? We're just trying to identify possible risk factors. Good? Are you sure? All right. If I ever go too fast, just slow me down, right? I won't take it out on you, I don't mind. This is actually what a slide that I intended to have earlier when we were talking about Jon Snow. And so this is a rendition of the map that he made during the cholera outbreak. And so one of the first questions he asked was, who is getting sick? So he took this map of this area of London and he put a little dot around every area that a person or a family was sick. And what he eventually started to note is that this water pump right here, that little red circle, right, was in the middle of it all. And so that's how he identified that pump. So he just, it was a simple question, who's getting sick? And he marked them, and that's how he figured out where the source of contamination was coming from. Right. And so it's nice.
So these build on each other.
Yes.
In a sense, okay.
Yeah, yes. And so the analytical next, right, so in the descriptive, you've identified possible risk factors, but you haven't really dug deep into, are they truly risk factors? So for analytical, we now take those risk factors that we identified in the descriptive study, and we start to try to narrow it down, all right? Find out, hey, some of them maybe we thought were risk factors, weren't, and maybe some of them, are just more important than others. So for the analytical study, yeah, we're narrowing down those risk factors even more. So it's a relevant risk factors. And you can do this in three ways. And, you could even say that this cross-section on this retrospective can kind of build on one another, even within the analytical study. So a cross-sectional study is simply something where I say, all right, I have an individual that is infected with a pathogen or disease in this case, and then I have an individual that's normal and healthy. And so I put them side by side, and I compare them. Right? This is often referred to as a snapshot of the population, because you're just trying to say healthy versus not healthy. Right? What's a weakness in just saying healthy versus not healthy?
Potential carriers or disease they can't see.
Wait, can you say that again, Lauren?
Would it be like potential carriers and people that they don't know have the disease? Like, I don't know how they measure health.
Okay, so that's interesting, right? So, yes, people that you think are healthy might not be healthy. Okay, that's definitely a possibility. Yeah. What else? If I just take a population and say, all right, Blair's sick and Michael's not, and then I compare them.
There's way too many differences.
Right, there could be way too many differences, right? Michael is a man. I was going to say a boy, but I know you're a man, right? Michael's a man, right? Blair's a girl, right? Blair's from Tennessee. Okay, I should know this because she's my advisor. She's from Tennessee. Michael is not from Tennessee. Fair, right? Michael, how old are you? 20? How old are you?
21.
Ha! Good, a year difference. Whew. And that's not a big difference. But let's say like Michael was 35 and Blair was 21, right? So yeah, Jennifer's right. There's a lot of differences that could be there, right? Age, right? Sex, race, culture. There's just a lot of things that could vary if you just kind of take a big snapshot of the population. It's better than nothing, right? Because at least you're comparing healthy and non-healthy, but it's still, right, we can do better.
So if they have a comorbidity, would that be taken into consideration with healthy and non-healthy, or is it just specifically looking at that one thing that you're trying to figure
Yeah, that's
out?
a good. So I would hope that would be taken into consideration. The problem would be, right, if there's something that we don't know about,
Okay.
right? So like that's what I would say the problem with like COVID would be, right, is that a lot of those patients that like are checking into the hospital, they had something wrong with them they didn't know before.
Right.
So again, if you take that snapshot, like maybe you're healthy and you haven't gotten it yet, but there's some type of underlying health issue that you have. You know what I mean? So then we just don't know. So yes. So this is where it gets a little better, right? It's the retrospective study. And in this case, what we do is we say, let's say Blair has the disease. Sorry, Blair. But what I would then do is I'd find, okay, a female that is also 21 years of age and a relative similar physical like condition, right? Nice and healthy. Or well, hopefully like Blair was, I guess, healthy, not anymore, right? And then I compare. So I would try to match, right? Female, 21. I guess if we're being really specific. Cleveland, Tennessee, right? To compare, to try to eliminate some of those differences, right, that Jennifer pointed out exist, right? So it's just trying to get a better idea, a better case control. And this hopefully would allow you to narrow down even more some of those risk factors. Now this one is really interesting. This is called a prospective study. And this actually involves identifying a whole people group. And so what you say is, okay, I think these 5 things are a risk factor, right? What group of people am I saying is susceptible to these risk factors? Or do I think these risk factors are prevalent in their population, right? And so I might say it's, I don't know, college students living in a dorm, right? So then I would follow them for a prolonged period of time and see if those risk factors prove to be relevant. Now, there's an ethical way to do this, which is the way that it should be done now, and it typically is done now, right? Where you inform, right, the patients that you're following them, and when things go wrong, right, treatment or intervention, right, is offered to those patients. There have been times in history where we have followed cohorts and not told them, right, or not been truthful with them. So if you've heard of the Tuskegee experiment, right, where we followed syphilis in African American communities and didn't treat it or offered them placebo for treatment, right, when they thought they were getting treated, right? So again, now, thank you, hopefully, to ethical standards, right, and review boards, that doesn't happen anymore. But these can be very powerful studies, right, if done correctly. Because again, you have a whole group that you can watch this kind of play out in. And then it's nice for that group because again, you would treat them and intervene when you saw something go wrong.
So would you define, I'm asking so many
That's
questions,
okay.
sorry. So would you define like when they say over 65 or whatever with comorbidity more at risk? Would that be a prospective analysis?
With the,
Like
yes.
with COVID?
Yeah, so I mean, you could, yes, you could choose to follow, I guess, a group of 65-year-olds, if you wanted to, like, other groups that you could, identify, like where a study like this would be strong, would be like in a nursing home, perhaps, right? You keep an eye on, their patients, and theoretically in the nursing home, and I know there can be variations, but there can be some similarities between those patients that you can. All right. So experimental, not quite as exciting, because it pretty much says what it is, but it is really important, right? So you've identified your risk factors, and now you start actually trying to treat. So you start drug studies, you start interventions that you think will help, right? You start trying to treat and figure out how to correct or reverse the effects of the pathology that the patients are experiencing. All right. And so, one of the ones, and I don't know if we'll talk about it, but if you've heard of convalescent plasma treatment for COVID, and they've actually tried this with Ebola. Also, does anyone know what that is?
Is that when they're taking the plasma from a patient that's had it and recovered and giving it to someone that's infected?
Right, and what's in that plasma? Why are they doing it?
Antibodies.
Antibodies, right? So the idea of convalescent plasma treatment is that if Hannah had COVID, right, and recovered, and this is also up for debate, she would theoretically have a bunch of antibodies in her system, right? When I say up for debate, we actually really don't have a clear idea of how long those antibodies are actually present. So you might want to get them while they're fresh, right? But then, right, Savannah's right. I would take Hannah's plasma and I would give it to, can you remind me of your name? Michaela. I'd give it to Michaela while she was fighting an infection, right, with COVID, and theoretically it would make her feel better or help her recover. The data is actually not conclusive as to whether that works or not, and that's one of the reasons we can talk about that. For something like Ebola, that's actually harder to even do because it's sometimes harder to find people that survive, right, from Ebola. But that would be an example of an intervention that we're trying right now for during this current pandemic. Yes?
What did you say that treatment was called?
Convalescent plasma therapy. I can post an article on it if you want. Gathering accurate data is hard because it's just definitely one of those things for ethical reasons. Giving someone a placebo plasma is not exactly kosher, and you typically are trying this therapy in the midst of some type of pandemic or epidemic, and so it's not like you've prepared for it and have this like elaborate research study. It's very reactionary typically when we do that treatment. But resmivir or whatever the one of the drugs that's being used right now, which was discovered at my air elbow pound. UAB.
Oh,
Yeah, you have the UAB talk. Come on, keep up with me, Blair. All right. So surveillance, right? We've talked about endemic levels of disease. So we get concerned, we get really concerned when there are changes in those endemic levels. Again, if we're talking about like rabies, whenever there's a case of rabies, we're concerned, but it's not declared a national emergency, necessarily. So measuring those, or keeping track of those endemic levels. We talked about MMWR, morbidity, mortality, weekly reports. So I've mentioned them before. I actually have a cool one that I'll reference here in just a second. That's from data that's gathered from prisons in the United States. Doctors send in information to the CDC and the World Health Organization when they identify notifiable diseases, and I'll show you that list in just a second, or when they see something kind of abnormal that is concerning. I don't have this slide on here any longer, but I think it actually is on the PowerPoint that's still on Moodle. This is actually how they discovered the start of the HIV epidemic in the United States. They had doctors from Los Angeles, New York, started sending in these reports in 1981 about men that had appeared relatively healthy, presenting with pneumonia and something called, I can't remember it now. Totally lost my train of thought. Alyssa, what's the cancer, epithelial cancer that HIV patients get that presents on the skin?
Is it cervical cancer?
I can't remember anyway, but they started presenting with very odd diseases that you typically don't see in healthy individuals, and so that was kind of the first kind of red flag that told us we had a problem. Right.
What's MMWR again?
Morbidity, mortality, weekly report. And I mean, the CDC, by no means a perfect organization, but they do a really good job. I mean, you can go to their website, and these are open access you can get the MMWR report for any one of these notifiable diseases that they have, and I'll actually show you a list. Sorry, the next slide of this. Yes, ma'am.
Is it Kaposi sarcoma?
Kaposi sarcoma. Thank you. Like it was just on the tip of my tongue. And Kaposi sarcoma is a cancer of the epithelial cells. Right, so you have a lot of epithelial cells, and in a normal, healthy individual with an immune system that's functioning, even if you have that, your body's able to keep up and remove the cancer on its own, and so it starts to show up in these patients, which we now know because their immune systems were not working. So the CDC and the World Health Organization have their hands full when it comes to surveillance, because we are we'll say a pretty integrated society, which I think you can appreciate now during this pandemic. We have a lot of different things going on that maybe we didn't have going on before. So one of my favorite, when it's functioning properly, is daycares, right? A lot of your parents, more than likely, and I know my parents, who are maybe the same age or slightly older than some of your parents, daycare wasn't a thing necessarily, or it was much smaller groups. You know, maybe the mom down the street, you know, kept 2 other kids from another family, right? But now we have, I call them disease cesspools. And I mean, the first year that my daughter was in daycare, I mean, it was like every 2 weeks. I mean, it's just insane. But theoretically, her immune system should be invincible later, right? I think that's how it works. We also have evolution of pathogens, right? Viruses, a lot of them mutate very quickly. The COVID-19, right, SARS-CoV-2, there's variations of that now. It's started to mutate. Influenza, right, that you maybe get vaccinated for every fall. It's constantly changing, right? That's why you have to get a new vaccine every year. We'll talk about this next unit. Antibiotic-resistant bacteria is becoming a huge, huge issue. And I think I have a link to it maybe on my one article, or on one of my presentations. It was a couple of years ago, a U.S., a lady, I mean, she was older, like 60s, 70s, but was in India, broke her leg, had an operation over in India, got a really bad infection, came back to the United States, eventually went back to the hospital, and they treated her with every antibiotic that we had available in the United States, and she ended up passing away, right? Because they're just the bacteria, we couldn't take care of it. Misinformation, right? Vaccinations are a good thing, but there is information out there that supports anti-vaccination, I think, movements, and I don't say that to vaccinate shame. There's been a lot of good research that's shown that they are very beneficial and that not having them causes issues. If we go back and look at morbidity and mortality, weekly reports of notifiable diseases, you'd see that things that haven't really been relevant since the 1950s have made a comeback, like measles, whooping cough. Some things that maybe you've never heard of, and there's a reason that you've never heard of them, because we vaccinate for them. But that's kind of fallen by the wayside. Holistic approaches. This is not me bashing holistic approaches. This is me saying that green tea, right, is not going to cure you of COVID-19, all right? Some people, right, take this as the only medical treatment that they get, and that causes a number of issues. This is my favorite, all right? Dr. Facebook and Dr. Twitter, and no, all right? I'm not saying that there's not truthful stuff on there, but consider your source, right? Consider who's saying it. And then modern life. Again, you can see during this current pandemic that modern life can contribute to the spread of disease. Modern life can make it hard to adhere to certain restrictions and guidelines that may be beneficial, right? So there's a lot of kind of crazy things, that are going on here that are contributing to the emergence of new diseases. All right. This is a list of the notifiable diseases that the CDC has. And again, doctors send in reports via these MMWRs to the CDC and World Health Organization for things other than what they see here, all right? But these are just examples of, if a doctor sees this, they are required to send in a report, all right? So every time, Abby goes in and has a tummy ache, which I don't think that happens very often for Abby, but, the doctor is not being like, ooh, the CDC will find this fascinating. No, right? This is just kind of their list to let them know. And again, this list, kind of changes depending on what's going on in the world. So like up here, it's alphabetical, so you don't see Zika. But I can guarantee you, right, a few years ago, Zika was kind of, the new addition, to the list. Here's SARS, right, severe acute respiratory syndrome. So this is SARS-CoV-1. Guess what's on here right now? SARS-CoV-2, right? And so again, this list can kind of fluctuate, but the ones that you see right here are a mainstay. And I can guarantee you that something like SARS-CoV-2 will now become a mainstay in the future, right? So there's flexibility to this list, but really essential in helping us monitor and know, have we changed from those endemic levels? And to Jennifer's point earlier, if people are following those guidelines and they're sending in that data, that actually can help us establish the endemic level of that disease. And so hopefully this isn't the case, but a few years from now, right, we have all this SARS-CoV-2 data and we see, hey, no matter what season or time of year, there's always this number of cases coming in. And so that's kind of our normal number.
I have a question.
I have an answer.
All right, so this might be a little dicey, but so with the way everything's going right now, in COVID, do we know if it's changing at all, or is it just one strain right now?
It has changed some.
Okay.
I haven't read the literature, but there is speculation. Yes, so yes, there has been change. Yeah, and we can even track. This is one of the things that made me chuckle. So Europe shut down, like basically said we can't come there anymore. And then if you look at least on the East Coast, and as it kind of spreads west, we were able to say that that strain of SARS-CoV-2 came from Europe. So I don't know, it kind of made me chuckle. I mean, we're like,
Okay.
so yes, but and there are, yes, it is changing now. I need to check the vaccine literature again because it's moving quickly. To this point, though, we still think that there's good enough targets that haven't changed that we can make a vaccine for this. But yes, it's already started to change. So.
Okay, and this is my second part. Is do you think it can be stopped? Like, do you think, and let's say you have the United States as a whole, right? Do you think it's possible to get herd immunity, or do you think this can be stopped? Let's just say we don't have that. I know it's a very dicey question.
Okay, loaded question. Alyssa, time, can you have a timer?
Yeah.
Give me 3 minutes. All right. So there's a lot of different factors that are in play. So one of the papers that you should be reading talks about post-immunity after infection. What we really don't have a firm grasp on is how long antibodies in someone's system that has already had it and recovered are effective at fighting the disease. So do I believe herd immunity is possible? Yes. Do I know how long it will last? No. The kind of issue when you approach it from that standpoint is, if someone is only immune for, I'll say 3 months. I'll throw that out as I mean, this is just me out of my time. The problem is with natural infection, that's kind of a rolling target, right? Because people are getting it at different times. And so I feel like picking on Abby today. So Abby gets it, right? And she's immune for 3 months, but then Alanis gets it 4 months after Abby got it. So Abby's no longer, right? So her number no longer contributes to the idea of herd immunity. However, right, I know for like SARS-CoV-1 gosh, I was reading, it's probably one of the articles I was having you guys read, that they do have, and again, it's not optimal immunity, but antibody levels that could provide protection for 2 to 3 years after infection. So in that case, it could be possible to achieve herd immunity. I'm guessing, and again, I hope I'm wrong, is that maybe the only way to get herd immunity is if we vaccinate, because if we vaccinate and we say, okay, this is the vaccination window, like October to December, everybody gets vaccinated then, so then theoretically their immune system, right, they've developed that memory. But even that, right, is kind of dicey because that might not last forever, right? And so the big question that I think is on everyone's mind is SARS-CoV-2 going to be seasonal like the flu? So are there going to be changes that maybe make a vaccination not as effective as we want? Will immunity only last a certain amount of time, so then it pops back up again and it starts cycling through? What's really interesting is that there's been some research studies, and it's one of the papers I had you guys read, that have shown when you get vaccinated for a live attenuated virus, it produces something called an interferon response, which we'll actually talk about in the next unit. And it protects against other viral infections. And so the article that you guys are reading talks about polio, an oral polio vaccine. When you get that, it actually protects from other viral infections. So what I'm super, super curious about, and I won't be able to measure this, is will influenza actually provide a little bit of protection for people from SARS-CoV-2, which is not the way I would choose to be protected, but right, theoretically, you get infected with influenza, produces an interferon response, and then maybe it actually causes a little bit of dip in the case of the SARS-CoV-2. I don't know. Again, time will tell. So I have no idea. I guess it's the short answer. It's just it's too early in the infection to know, and this is what makes me nervous about the vaccines that are going to come out quickly. Is I don't think a bunch of people are going to fall over dead, but I think it could possibly create a false sense of security because we have no idea how long that vaccination is actually going to protect. But I mean, sign me up. I'll be online. Actually, I'll probably give one to Morgan first, see what happens to her. But you know, it's a moving target. There's a lot going on. All right, Alyssa, was that 3 minutes? Did you can time me?
4 minutes.
4 minutes. I told you.
You're on a roll, though.
Yeah. Alyssa?
Yeah.
No, you're Alyssa. Alyssa, keep an eye on Alyssa for me, all right? So really quick, and I can actually show you this report. This is from an MMWR that looked at the U.S. prisons. I don't know where some of you are from in your hometown. Where I went to college, though, there was a Walmart, the college, a federal prison, and a state prison were the major employers of the county, right? And so it was kind of interesting because this was Huntington County, which is population nothing, but they made it like this one big like red spot smack dab in the middle of Pennsylvania during the pandemic early on because they had it run through their prison system, right? And so one of the things that's interesting is during pandemics like this, I think there are certain populations that we forget about, and one of them is prisons. And so we have about 2.1 million people in prison in the United States spread across 5,000 prisons, all right? And so this is data that was collected in late April, and this is with an incomplete report, right? And so some of you may know, how many states do we have? Bingo, right? And so we have, right, some territories, so that's why you see the 54. I just want to let you know that I do know basic, basic civics and history and fun stuff like that. But 86% of these 37 jurisdictions that reported had at least one case of COVID-19. And at the time, and again, this was a while ago, so I can guarantee these numbers have gone up. I'd have to go and see if they updated it. They had around 5,088 deaths, and then they had 15 deaths. So that was prisoners, and then staff is below that. And what's really interesting, right, about prisons, and please notice some of the links between prisons and dormitories, right? Although you guys do have your freedom, but it is kind of an interesting comparison, right? Crowded dormitories, Shared bathrooms. Huh. Man, I guess we could even say liminal medical isolation and isolation resources. You know, daily entry and exit of staff and visitors. Huh. Arrival of new students. Huh. Right? Group transportation of students. I see how you can kind of fill it in there. So it's just kind of an interesting study that shows you, I think, some of the challenges and areas that we don't forget about. We appreciate the challenges that are happening here and the things and the measures that we are taking. And there are things that we can do here. And I'm just joking. I don't think dormitories are prisons. I lived in one for 4 years, and look at me now. All right. So, but it is kind of an interesting comparison when you look at it. And this is my favorite. These are the kind of the recommendations. And I think one of the things that maybe you guys can appreciate is that the recommendations are constantly changing. And that's to be expected because we're constantly learning new things. And I know you might not find this shocking. Sometimes the regulations are almost impossible to adhere to, right? It can be very challenging. And so, you know, the dormitory thing aside, I think you can start to appreciate in a prison, how do you socially isolate in a prison cell, right? How do you socially isolate in a prison cafeteria? It's really, really challenging in certain facilities to make this happen. And again, you know, I kind of joke about Huntington County where I went to college, but this was an issue in a lot of prisons. And what becomes very challenging too is that staff members at prisons often work at more than one prison. And so there's a fear there that if one of them's sick, they take it to another prison, or if they get it from working at a prison, they take it home to their family. And so, right, and so there are a lot of interesting, I think, challenges again. And that's what I was trying to kind of show you in those different papers that were just kind of all over the place for this unit, is that pandemics are really, really complicated. And there are a lot of things that we don't have to think through, we don't have to worry about, that someone is having to think about or worry about, right? And regardless of what you think, right, of prisoners in our penal system, right, I would argue or say, and I think hopefully most of you would agree, that they still do have a right to be protected from certain pathogens and diseases, right? And so there's just a lot of challenges that either we're not aware of, and you know, thankfully I think for some of us we don't have to deal with. It would be very challenging if I said Ashlyn. No, oh, wait, what did it start with? It starts with an M. Mashlyn? Michaela. Not even close. Right as I said, Michaela, figure out the prison problem, right, in Bradley County. Right? So we'll finish up with this on Friday. Thank you.